Hello everyone, I am RUCHITHA with my batchmates PRASANNA and PRATHYUSHA under the supervision of Dr. L. Jaykumar, Associate Professor of Weltech University. We are here to give project demonstration of our project. Let's get started. This is the agenda we goes on, and this abstract of our project explains that COVID-19 is worldwide disaster. To take a prevention and get rid of it, social distancing is the major protocol. Since vaccines are out, but this distance is necessary for every individual safety. So we used CNN technology to overcome this problem. Aim of the project is to create an application to monitor people to follow distancing. And scope of the project is to build a device that overcomes social gatherings. And coming to introduction of our project goes as based on the COVID-19 will not wear get togetherness to safeguard their well-being from contamination. And we taken 6 literature review to enhance our project and to implement more possibilities. And coming to methodologies, in module 1 video uploaded and module 2 YOLO model acceptance, in module 3 processing module, in module 4 detecting social distance. These are standards and policies we are used. This is architecture diagram of whole project, and this is DFT diagram of project. This is the sequence diagram and next collaboration diagram of our project. We used unit testing and integration testing to test our project. It results as it can detect about 500 or above frames at once. This is our input video screenshot, and this is our output we got. Finally, I conclude that using human phrasing dataset with mean level accuracy, we completed our project, and the strategy will notice applications in advanced tasks. For future enhancement, we can use facial detection or mask detection. We are here to give a video demonstration of our project, Distant Socializing Surveillance using YOLO algorithm. Let's go ahead. Let me give justification of our project title. Distant Socializing Surveillance means detecting the physical distance between two objects or persons. This protocol is very necessary in this pandemic. And next, using YOLO algorithm, as its name shows that YOLO, you only look once. It predicts the kind of position of an object just by seeing the image one time. Let's understand YOLO's reality. Eye is the major part of human body to see everything in the nature. It sends to brain frame by frame and decode it and make sure that object is being detected. Well, it sounds pretty to understand, but the principle is same. When it comes to brain, it detects within seconds, that is beyond our comparison. Let's dive deep to understand it. Major challenges to detect an object are variable number of objects, multiple spatial scales, limited data, modeling, speed of real-time detection. These are accepted by YOLO. Why YOLO is better than other CNN algorithms? Let's consider some challenges and compare algorithms. Comparing YOLO with faster RCNN, and let's see how YOLO hits it. Based on the comparison of inference speed and detection of small and far away objects, YOLO gets right choice. And next, little to no overlapping boxes in the below given images where we can see YOLO has no overlapping. If you consider in a crowded area, YOLO makes sure to detect the objects. So this gives an inference that YOLO has an obvious high operating.
Hello everyone, let's continue with the project demo. As per the guidance of WHO, physical distance is the best prevention in this pandemic. So we came with an initiative using computer vision technology. The system detects and alerts the person if the person is above the minimum range. So distance between the persons is calculated based on the Euclidean 2-point formula. So let's get started. Here we used 4 modules. Coco.names, YOLOV3 CFG, YOLOV3 weights and video surveillance. Let's open this in VS Code. So here we can see that the 4 modules are open. That Coco.names contains the whole list of YOLOV3 detecting objects. Contains like person, bicycle, car, motorbike, bus, train, truck and etc. But we necessarily used only person object as our project is about to detect the distance between two persons and calculate the minimum range. So let's see another module like YOLOV3 CFG, which contains the whole standardizations of YOLOV3 file and which use it to calculate the bounding boxes and confidence score of an object. And next in YOLOV3 weights, which contains the whole output to detect the object in a frame by frame manner. So let's go to the main module. In main module you can see we are importing two files like OpenCV and NumPy. These OpenCV and NumPy is used to detect the objects and further numerical calculations, and we are invoking two variables like confidence score and the threshold value. And next we are seeing the video path how we are giving an input to our execution. So here we can see that the two functions has been invoked like calibrated distance to calculate distance between the persons and isClose method to return the status value if the persons are in minimum range or not. So and next we can see that the weights file and the configure file of YOLOV3 weights and YOLOV3 CFG. And further we are going to while true, if the while true function is while true loop is invoked if the output has been detected in a frame by frame manner by using boxes, confidence scores and class IDs. And next, by calculating the centroid value of two persons on an object, this distance has been calculated, and based on this risk factor has been returning by returning the risk factors as values of g is equal to 1 and r is equal to 2, and it returns the values of status as 1 or 2 by calculating the risk factor. If g is equal to 1 and g is equal to 2, and we are giving an output as 2, total number of persons, low risk persons, high risk persons, and by saying that the count value is 2 for the low risk, count value is 1 for high risk, 0 for the safe. And next we are annotating these status values as by connecting lines showing among the persons like yellow as close and red lines as very close. And next we can go to the bounding boxes by calculating the level of risk. If the high risk it is detected by dark red and low risk it is an orange. Green boxes are detected if the persons are in safe, and it shows an output like total count and high risk count and low risk count and safe count. So finally we are returning the 4C function for radioator to stop our execution. Here we see in the how code explanation has been taken. So let's execute it. So open command prompt. So here I shown the steps how we want to proceed for our execution, and open command prompt and type the command directive where your Python file total file location has been located, and save that whole files in a single folder, and go and just paste it and press enter and type that Python directive, Python main module directive, and copy it and paste it. Press enter. So it executes and it takes time. So here we can see that the how output has been executed, that it shows that green boxes and red boxes and red lines also is showing that, and yellow lines. To detect that yellow lines means it's persons are in close, red lines are detected if the persons are very close. If the red boxes are detected, the persons are high risk, and green and are safe, and orange the persons are in the low risk area. So I am showing that original video also. So see. So here we can see the original video how we had it, and see the final video how we got. So that's all about our project and for calculating the surveillance. So have a nice day. Thank you.